Aloha guys, this is Dr. Tom Walker coming at you from somewhere in the Hawaiian Islands. This is our introductory lesson for my new YouTube channel, where we're going to talk about, in great detail, the paranormal psychic phenomena, subtle energy, consciousness, and a variety of other things. I'm doing this because it's time to get the word in the streets. It's time to cut through the BS out there and the constant criticism of psychic research and talk about the truth. And when I talk about truth, I mean it with a capital T. I'm also here to promote my book. I spent 7 years researching it and writing it, many more years getting it published, and it's time to get it out and get it moving more. You can see it here. It's called The Forces With Us, the higher consciousness that science refuses to accept. One of the most amazing books you'll ever read. Now, I say it in a joking manner, but I'm quite serious. Yes, it is good. Okay, I'm going to do lots of shameless self-promotion like that. If you're offended, well, go buy the book and judge for yourself. All right, the topic today is, to start with, is strange energy in a strange world. Okay, for many, many years, Newton's time, they thought they had everything figured out. The universe was comprised of indestructible particles created by God that bounced and ricocheted off each other like tiny billiard balls in such a way that could be predicted. And ultimately, everything in the world could be understood. And this belief held tight for several centuries. And my great hero, Albert Einstein, was the first one to knock it off its pedestal. I think he kind of felt a little bad about it because Newton was a great hero of Einstein's as well. So in the early 20th century, 1905 and 1915, Einstein published his special relativity theory and his general relativity, which changed the way we think about the world in a great deal, a great manner. Things weren't as fixed as what we thought they were. And then, to Einstein's great consternation, a few years later, he helped kick off the development of quantum mechanics, which a lot of which he didn't like, but he actually, his work laid a lot of the groundwork for the development of it. What was thought to be a mechanical world of solid particles created by God that interacted in a way that could be predicted and understood, Newton's view of the universe, suddenly became a seething mass of unimaginable energy fields where virtual particles popped in and out of existence, and even the position and momentum of a single electron couldn't be known for sure. Just for fun, we'll talk about some numbers here, just because I always forget. Over the years, the numbers have changed, but eventually cosmologists settle on there being some 10 trillion galaxies in the observable universe. And since our Milky Way galaxy was ultimately determined to have approximately 100 billion stars, something we're going to point out very shortly down the road in another video is it's the same number of neurons in the human brain. When we multiply these numbers, we arrive at the total number of stars in the known universe, 1 times 10 to the 24th power. Enormous. Now, I mention this for a couple of reasons. One, it's fun to talk about it. And it's interesting and to think, how unimaginably gigantic all this stuff is. But also, we're going to see that these numbers change. Every so many years, they're reevaluated, and suddenly, bingo, the old thing was wrong. They were wrong again, but they're right now. This is the last one. This time they're correct, huh? Yeah. I see no need to consider these as the final values. Okay, my hero Einstein was a believer in what was known as the steady state theory. Now, this was in the early 20th century. The Big Bang had not been proposed yet, or if it had, it was brand new. And Einstein was a reductionist type person, in spite of the amazing, mind-blowing, world-altering theories that he developed. And he liked the idea of a steady state. The universe has always been, it's always going to be, everything's cool. But in 1929, Edwin Hubble, from whom the Hubble telescope is named, discovered that the universe was expanding, and this came as a great shock. He did so by observing the redshift of galaxies. Einstein was not happy. And so Einstein proposed what he would later say was his most embarrassing blunder. He proposed what's known as the cosmological constant. Here's what I've got. He modified his complex gravitational equations by adding a fudge factory called the cosmological constant. This proposed massive sea of unknown energy in the cosmos was able to bring the mathematicals back to a steady universe again. Einstein was nervous about it all, but he had difficulty accepting the idea that the universe was expanding. Now, a few years later, it was conclusively demonstrated that it is. And so Einstein sheepishly admitted that the cosmological constant was his greatest blunder. And what it was the idea that there's a massive amount of undefined, strange, mystical energy in the universe. And because of that, the enormous gravitational fields from that would halt any sort of, and prevent any sort of acceleration of the universe. And they were just, they were imagining that. However, there's more to the story. Redshift. In the 1990s, two teams of scientists were using the Hubble telescope to study type 1 supernovas, and they found something startling, amazing. Not only is the universe expanding, which we've known since Edwin Hubble, but the expansion is accelerating, it's speeding up. This came as an enormous shock, but there's enough proof of it that it was accepted. On the surface, this just wouldn't be possible, but it was. Now, the expansion of the cosmos is due to the outward movement from the Big Bang some 13.7 billion years ago. The conventional thinking was the mass of the universe produced enough gravity that it would slow and eventually reverse the expansion. It would draw everything together over billions of years into what's called the good big crunch. And then maybe there'd be another Big Bang and it would run in these enormous cycles. The reason they follow this line of thinking is there just wasn't enough, there's not enough matter and energy in the universe to be responsible for this accelerated expansion. That's the thing that's so mind-blowing. So what did they have to do? They had to come up with something, and so they invented something called dark energy. And the dark energy is what's causing the expansion. The expansion of the universe is speeding up, but there's too much matter and resulting gravity to allow this, so scientists created a placeholder, the existence of a strange, undefined, mysterious energy that pervades all space and is actually a form of anti-gravity, pushing the space-time fabric of our world apart, with the galaxies just tagging along. Scientists desperately needed something to understand this, so they brought back a blast from the past, the cosmological constant. There it is again. Now, this was after Einstein had already exited this world, but maybe he'd be proud because actually what he thought was his greatest blunder turns out to be of major importance in explaining this dark energy. Here's a copy of Science magazine talking about the reincarnation of the cosmological constant. Here's the formula. Here's the great constant itself. In physics, when something is poorly understood, it's often termed dark. There it was. They called this all-pervasive, unknown, mystical energy. That's my word. Dark energy. Excuse me. The dark energy, or the cosmological constant, was said to be everywhere in equal amounts, a part of the actual fabric of space-time, the most fundamental aspect of our world. And as the universe expands, more dark energy is just created out of nothing. Now, that's science's words, not mine. There are a couple of additional theories, but the dark energy theory is the primary one, the ones that's primarily accepted. So the universe is expanding, and the expansion is speeding up. Okay, quantum theory. The actual term is quantum mechanics, but what the heck. One of the superstars of the development of quantum mechanics is Werner Heisenberg, who's known for his famous uncertainty principle. And he plays a big role in this, so we need to talk very briefly. We'll discuss quantum mechanics another time. Yes, no more than what we have to, but one of the major ideas was created by the great Werner Heisenberg, who gave us his famous Heisenberg uncertainty principle. Briefly, in modern theory, particles in a virtual state are constantly popping in and out of the vast dark energy fields. Because the act of observing or measuring a particle changes its location and momentum, we cannot state these values for sure. And the better we know one, the less we know about the other. Here's why, guys. Number one, everything is a sea of mystical energy. More on that here in just in a moment. And the particles that make up matter are in a virtual state. Now, this is accepted theory. Blows away Newtonian physics for sure, although they can still be used, or it can, to plot the orbit of the moon or to rendezvous with a distant satellite 1,000 years from now, etc. Okay. But I'm getting ahead of myself. I'm sure it comes as a shock. When these particles manifest themselves due to certain reasons, in order to observe one, we have to bounce photons of light off of it and back to our eye or to our instruments, so we can watch it. And that disturbs the trajectory or the energy state of the particle. That's what Heisenberg is talking about. Now, the reason we bring this up now is because the Heisenberg uncertainty principle plays a big role in the establishment or development of dark energy. This unimaginable roiling of virtual particles in the titanic sea of dark energy creates a vast, fundamental, mysterious energy in all of space-time. And the leading theory of quantum mechanics, the Copenhagen interpretation, says that the particles don't manifest as, quote, real out of the dark energy until they are observed or measured. Now, this is well known, but there's still a lot of you may not know that. Some even go so far as to suggest that human consciousness is required to manifest particles. Oh, we're going to talk about that, and we'll have lots of fun with that very soon. But there remained a massive problem. The massive, indescribable bulk of dark energy pervades all space. It's been explained by the cosmological constant of Einstein. The Heisenberg uncertainty principle requires that it be a seething plane of constantly forming virtual particles which disintegrate back into the energy. Dark energy is said to comprise 70% of the entire cosmos. Its strange anti-gravity properties are pushing the cosmos apart with an accelerating velocity. We don't know what it is after 30 years of study. And even more mind-blowing is there's too much of it. Now, this aspect of dark energy has come to be known as zero-point energy or quantum vacuum energy. We know it's there because the Heisenberg uncertainty principle requires it. There's some experimental evidence to verify it, including the famous Casimir effect. More on that later. The problem is that the equations predict that the amount of zero-point energy is some 120 orders of magnitude greater than what's actually measured in the universe. Now, briefly, guys, an order of magnitude is times 10. So that's times 10, 120 times. Excuse me. A cup of it is said would boil of dark energy, or zero-point energy, but it's the same thing, would boil all the world's oceans. 1 cup. Amazing. But we know it has to be there. Okay, zero-point energy is called that because it's the energy that remains even when we reach the temperature of absolute zero, when all molecular motion stops. However, the vast primordial energy field is always in motion, condensing to form particles which fade back into the energy fields. Besides the equations in the Casimir effect, another example that verifies zero-point energy is liquid helium-4. Even at absolute zero, it remains a liquid. Eventually, a gas like helium would freeze solid if you got the temperature down enough. But the reason it doesn't is because of this zero-point energy. It doesn't freeze solid but at normal atmospheric pressures. If you modify that, it's different. The vacuum energy provides the additional energy to keep it liquid. The problem remains that the equations predict enormous amounts of energy that are difficult to accept. In fact, we know the equations have to be wrong. If there was that much energy, the universe would have accelerated exponentially, and there wouldn't have been times for galaxies and planets and Earths and moons to form. My time is up. We'll continue next time.